say something? Ah, now I hear you. Sorry.
Can
Yeah,
you hear me now?
Yeah, now we can hear you. Sorry for this. Yeah, this is also for us a first, of course. But
Okay.
sorry, so I couldn't hear your answer.
No, it's okay. It's normally me that has the muting issues, so it's good that it wasn't me for a change. Yeah, I am in sunny Greater Manchester at the moment. I say it's sunny. Okay. It's absolutely pouring down. It's a bit miserable here. It's
so
normal.
That's probably why your racing bike is on the wall instead of outside.
Unfortunately, yeah.
Okay. Well, Joe, thanks a lot for being here, and you're welcome to go ahead and share your presentation.
Yeah, brilliant. Okay, so let's just get the presentation up on the screen now. Fantastic. So yeah, hi everyone. My name's Joseph Kearney. I'm Costain's automated design lead, and my presentation today is on people, process, and technology, and how we need all three to help us automate design at Costain. So a bit about me, just again to reiterate, I've been with Costain for about 9 years now, background in engineering, chartered mechanical engineer, and I've led our automated design capability for around 18 months now. So just a little bit about Costain for those of you who may not have heard of us. So we have over 150 years of history of designing and building some of the UK's most critical infrastructure across energy, water, transportation, defence and nuclear, as well as helping our local governments. So I've tried to choose sort of 3 examples of that sort of capture the breadth of the work that we do and the complex projects that we've delivered. So going back a few years, we were part of a consortium that delivered the Channel Tunnel, which is the part of the rail link between London and Paris. The second image is our work in the nuclear sector and the delivery via ship of some of the evaporator modules for Sellafield, which is the world's first commercial nuclear power station. And then the third one's more recently some of the major complex projects that we're delivering. So this picture is the launch of one of our tunnel boring machines for the new high-speed 2 line between London and Birmingham, and we're also involved in the Elizabeth line, which opened probably about this time last year. So how does automation and automated design fit into that? How does my team fit into that? So this capability in Costain is around 4 years old, and we are fully embedded as a key part of our in-house design and engineering team, and we report directly to our chief engineer. And I think that's really important because it means we're in the same team as our designers and our engineers, and we have that direct input and that shared accountability for improving processes and automating our design. So we're not a standalone team that sits out of the way. We're really part of that team. So what we can do, what we do as a team, we across the design and delivery lifecycle, from feasibility studies to detailed design to supporting our site teams on our construction projects. But I've tried to break it down here into 3 rough pillars. And the first one is optioneering solutions. So the development of parametric tools that will give us the information that we need to make decisions. Or if we go into a more detailed design space, so looking at our computational engineering tools, looking at automating things like structural analysis of simple repetitive design, and I'll give a couple of examples of these a little bit later. And then the third pillar, we're increasingly using lots of different pieces of software, and our engineers are spending lots of time manually handling data. So how can we automate the process almost that avoids doing this? So why are we doing it? Hopefully most of this audience will be fully on board with these points. The traditional design process, we only really have time and budget to produce a small number of solutions or investigate a small number of solutions. Significant effort and time and budget is needed to test the outcome, the viability, the sustainability, or the costs of these solutions. And our view is that parametric tools and parametric design gives us the ability to calculate lots and lots of different solutions and optimize options against different metrics, and gives us a better chance of delivering better value for our clients. So we also have lots of engineering experience that's locked away in people's brains, and this is about unlocking that experience that our engineering team have and capturing it for future use, so we don't have to go back to the drawing board at the start of every new project. And what if we could link our processes to our designs rather than just referring to them as a sort of standalone document? So how do we do it? And one of the key tools in our arsenal is visual scripting, which I'm sure most people here will be familiar with. Our team are engineers. We're not computer programmers. You know, these are often low or no code solutions that are driven by digitizing the logic behind the design. So that makes it really accessible to our engineers. So you don't need to be able to write complex Python scripts to build and run these tools. Although I am looking forward to some of the sessions this afternoon on Python coding for engineers and, you know, what the future of engineering looks like. I think, you know, especially in the UK, from what I've seen, a lot of degree courses in the UK, our next generation of engineers will be graduating with these skills. But for now, we see visual programming as lowering that level of adoption for our, you know, our current engineer skill sets. Our engineers know the logic that goes into their designs, so they can build these scripts themselves with our support, and that's what our team are here for. So the key to these things is often starting simple. So in our civil and structural engineering team, for example, we've done just that and looked at how we could automate the design of reinforced concrete slabs, for example, that support equipment kiosks. You know, really simple example, limited variables, designs relatively low in complexity, and is usually repeatable. And we do this a lot on our projects. And the idea here and the power with these tools is that we can link the calculation to the key parameters in our visual script. We can also bring in the structural analysis checks. Our structural analysis software is live linked to the geometry creation, so we don't have to pass information manually back into between designers and engineers. It is all linked in one script, and we can then play tunes with that. So our engineers find it really powerful to be able to play tunes with the design and say, you know, what is the minimum that we can get away with to produce a code compliant design? We don't need to be massively over engineering these tools. We can use this script to minimize material usage, and then we use that to then automate calculations, drawings, reinforcement schedules, get materials quantities, and etc. for checking. So we're producing design deliverables in a fraction of the time. So these scripts and this digitized logic we're using across the things that we're developing. So whether it's a concrete slab for a kiosk or a storm tank for our water sector projects, which is essentially a reinforced concrete box, or a car park for one of our site compounds, which, you know, the key theme here is that we really shouldn't be drawing these from scratch every time or designing these from scratch. Or the image on the bottom left, for example, is a working platform design for our temporary works design team. We're developing tools with our engineers for our engineers. Sorry, I skipped ahead a little too soon there. Working with our engineers, developing tools for our engineers to automate the repetitive bits of their work. So another key opportunity to capitalize on automation and use automation that we've found is for the design of long linear infrastructure projects, like roads or pipelines, which brings us to the image on the right and a product that we call URoute. Now, URoute combines geospatial data with engineering analysis to help us route cross-country pipelines and do it in a way that's going to be transparent, repeatable, and scalable. So some of those points that I highlighted a bit earlier is why we're doing this. When we started developing URoute around 4 years ago, and we've used it now on multiple energy and decarbonisation projects across the UK. So applying similar logic, and we're now applying that similar logic to other linear infrastructure projects. So, for example, rapid transport schemes and potentially high voltage cables and other pieces of linear infrastructure. And the key thing here is that this isn't a black box. It's a process that our engineers have developed and are still developing. So it provides that greater insight and transparency in the design decisions that we make. So it combines GIS tools with engineering insight. We've built it again using a visual script that engineers can interrogate, and we have the control to change that script. So I'm just going to show a quick example of how we use that software to combine that engineering knowledge and, you know, key considerations for a linear infrastructure scheme, such as a pipeline, and how we've really accelerated the decision-making process. So on the screen here is almost a blank canvas. So this is an example project that we did a couple of years ago now, and we really start by capturing our client's problem statement, so we can build in various push and pull factors or penalty scores. Do we want to, you know, do we want simply the shortest route? Do we want to follow an existing route? Do we want to, you know, ignore, or do we want to take into account particular landowners? initially here on this map, what we've done is we've excluded occupied buildings. So a simple rule for routing a cross-country pipeline is that you can't go near or under people's houses. So we can use the data set that we have for the whole of the UK to remove those from consideration. Now, we don't know where the pipeline is going at this stage because this is for a feasibility study. So let's just imagine that it can go through any of those green pixels. We would then want to classify those based on other infrastructure and other things that are there. So as we add complexity to this map, so for example, we want to avoid areas of steep terrain, we might want to avoid crossing under motorways more often than we need to, railways, roads, all that good stuff with environmental designations, for example. And we end up with a bit of a heat map that then gives us the big picture within that study area. So this is obviously a simplified version. We've not got stuff on here such as wind turbines and other utilities and things that might not be publicly available, but we are basically penalizing areas that are less suitable for routing from A to B. Now, as we don't know where the pipeline's going, and we maybe want to use the power of computation to give us that answer, we want to potentially route through every single pixel and give it a score. So that's what we do with our geospatial software. So we then take, and what you should hopefully see on the screen is as we calculate the cumulative cost to route from A to B through every single pixel, we then start to be a little bit more selective about the pixels that we want to see. So we might not be interested in going through the pixel in the very top right of the map because the score is ridiculously high. So we may only want to see, say, the top scoring 10% or the top scoring 5%. But what we can do is we can really quickly filter out the rubbish that we're not interested in and focus in on the key routes. And then we can play tunes with the weightings to give us various different options. And this is where this tool really goes beyond a simple geospatial exercise. So, for example, on paper, you might think the shortest route is the cheapest, but the shortest route may mean that you actually need to use more material because you're closer to populated areas, so you need a thicker pipe. There's lots of factors at play here. It's not just a simple, let's just pick the shortest route from A to B. But the power of this tool is that, you can really quickly see the impact of any change. So, for example, if we're negotiating with a landowner, we can quickly visualize the impact of having to go around their land or avoid their particular plot of land. We can simply add that data in and rerun the analysis and see where the difference lies. And depending on the size of the size of the study area, that sometimes it's a case of going to make a cup of tea, coming back and it's rerun, or it may need running overnight, depending on how long how large the study area is. But again, like the reinforced concrete slab tool, we're also developing scripts that sit onto this that will look at automating the production of the design deliverables, so route maps, schedules for reports, and we're seeing a significant reduction in the amount of manual data handling. So you think of how long it would take you to produce maps of these routes if you've got a 200-300 kilometer pipeline or a 200-300 kilometer road. You don't want to be doing all those from scratch every time. So having scripts that will do the donkey work, do a bulk of the work for you, it's never going to spit out a complete deliverable. It's always going to get you a certain percentage of the way through, but we find that really powerful. So yeah, to bring this back, I suppose, then to the title of the presentation, I've talked a lot about how we're giving our engineers a platform to turbocharge what they do, and then how we're digitizing the processes to make us more efficient, but maybe less so much on the technology that we're using. So this slide that I showed earlier obviously gives a lot of examples of the software tools that we use. So most of us will maybe recognize a Grasshopper script on the left there for parametrically modeling some geometry in Rhino, and the URoute pipeline routing tool that I've just showed an example of uses a visual scripting script from data manipulation software FME, and then Model Builder, which is built into ArcGIS, which is the geospatial software. All of this needs lots of software, lots of licenses, or needs us to remote onto a virtual machine, which takes time to set up. So maybe what I just want to finish and touch on is what if someone just wants to jump on and have a quick look at something? What about our site teams that maybe don't have the software? They just have an iPad, or they're out on site and they maybe just want to gain some insight from these tools. And this is where I think web-based tools like VIKTOR come into their own and have a real benefit. So what I'll finish with is something that we're working on at the moment with the VIKTOR platform and how it can help our project teams make better decisions. So I just flick over. So this is in development at the moment. We're really close to being able to share it with the community once we've trialed it on a real project. So this is a tool that we're working with our sustainable design team on, and it's the development of a decision-making tool for different types of a site haul road. So again, it's based on relevant UK highways codes, but the idea of it is it helps us to quantify the total embodied carbon of a haul road, and then combined with materials and maintenance cost, it will really help our site teams to make a data-driven decision. Again, like a slab, like a tank, like a pipeline route, this is something that we do a lot of in Costain, and we maybe do it without taking a step back and thinking of whether this is the right thing to do. So again, if we're digitizing this decision-making process, and let's follow, if you see the triangle on the right-hand side is a net zero design triangle, which is adapted from PAS 2080. And we can use the VIKTOR platform to set questions. So we should really be challenging this brief. Have we considered alternatives to a haul road? Can we get material onto our sites in a different way? And only when we have to build something are we then allowed to proceed and produce a design that's optimized against carbon and cost. So we think at the planning stage, this will be a great tool to rule out different types of haul road depending on the conditions. So it'll let us provide live comparisons to a number of different haul road options in real time. We'll be able to see how a change or an improvement in parameters will increase the efficiency of a haul road. So for example, not being a civil structural engineer, I wasn't aware of how much of an impact the design life of these haul roads have on the decision between, say, a stone haul road and a concrete haul road. I would assume that a stone haul road would always be, always have less embodied carbon than a concrete haul road. But when you take into account the maintenance of these things every 6 months, you've got to reapply stone and things like that. Using this tool has been a really great illustrator for the break-even point for some of these decisions, and yeah, the power of it being web-based is that anyone with a laptop or a phone can access this tool. So it's still early days with this tool, but we hope it'll become part of a suite of digital tools that our teams can use to make better engineering decisions. So that was it from me. Thanks for listening. I suppose a little bit of a whistle-stop tour through the work that we're doing at Costain to support our engineers to automate and improve our design efficiency. So yeah, I'm happy to take any questions, and yeah, hope that was interesting for people.
Thanks a lot, Joe. I really liked this presentation. Really impressive to see what you are doing. Yeah, so first of all, maybe to let everybody know again, if you have any questions for Joe, just let them know in the chat. And next to me, there's Anande. Anande is moderating the questions. So then Anande will make sure to ask them to Joe. So first of all, Joe, I had actually also a few questions. So one was more sort of regarding this process. So could you maybe elaborate a bit on how sort of this team looks like? Is it because we often see, of course, that you have a project organization? Is it that people just running on the project are also partly developing these tools, or is it really sort of a separate team who is developing the tools and then bringing it into the project? Could you elaborate a bit on how that looks like?
Yeah, sure. And I think we've tried a number of different ways, and I think we're still exploring different options for developing these tools, because I think go back to what I said about these are tools developed by our engineers for our engineers. I'm not, I have absolutely no ambition to hire a civil structural engineer and bring them into my core team, because we have a civil structural engineering team. Yeah. What we need to do, in my opinion, is give them the time and the space to be able to develop things for the business. So
Yeah.
you know, taking them away from projects 100% to maybe focus, you know, even if it's on a part-time basis to start with, on developing these tools. We've got, you know, our engineers know and see the inefficiencies as part of their job. You know, they see them and experience them every day. So
Yeah.
I think they're perfectly placed to then come into our team and help us develop them. And you know, going back to the comments I made about the next generation of engineers, our engineers are going to be able to code. Our engineers are going to be able to use visual scripting tools. So we should capitalize on that, I think, and bring them along for the ride. But it's, you know, I think it's a journey that we're going through at the moment, and but I think that's worked better than, you know, just parachuting a digital team or a separate entity into our engineering team and saying, look, we can help you. You know, you can do this better. It's not the right, you know. I think we've had more success sort of supporting our engineers to develop these tools, if that makes sense.
Yeah, that's I can imagine. That's also what we quite often see, is that because I think it can be quite a challenge. I also have the feeling too, because often when you develop these kind of tools, also in projects, it of course at first you have to invest some time, and then it takes some time before it sort of brings added value.
Mm-hmm.
So is this something that or how does that work sort of investment wise on your side? Do you develop the tools really sort of on the budget sort of project, or do you really have a separate budget to develop these kind of tools?
I'd say a bit of both. We can't, you know, there's obviously got to be some investment in the team to develop these tools, but yeah, I think having, you know, we have a training budget as a business and an opportunity for people to try new things, and I think going back to what I said about starting small, I think that, you know, that's really important. If the business can see the benefit of developing something for a certain application, I think it makes that business case a whole lot easier to make. You know, if we say we're going to develop a tool that's going to take us 18 months, 2 years to do, and then we might see a benefit 2 years down the line, you know, we're not. I don't think many companies have unlimited development budgets at the moment. So it's, I think some sort of key features of the things that we're creating is, you know, start small, fail fast, know when to drop something if it's not working, but also not trying to do everything in one go. You know, if we can just nibble away at some of the inefficiencies, then that's a great start.
Yeah, great, cool. Yeah, and I also really like the tool where you also look at embodied carbon. I think I saw sort of a glimpse of it at some point, and that actually sort of the first question in the tool was something like, "Do we even need this road?" And I think that's super cool also because I can imagine at the end, it's as a company, if the answer would be no for your business, that actually wouldn't be a good thing. But I think it's really cool that you ask yourself this question: is this really necessary to build?
Yeah, I think it's a bit of a cultural shift, you know, as in a business that ultimately builds things. You know, we get paid to build things, but would ultimately, you know, we're here to satisfy the needs of our clients, and our clients would be probably more delighted if we told them that they maybe didn't need to build something rather than building something well. And it, you know, I think ultimately it comes back to that, you know, let's just take a step back sometimes and question, do we actually need to build something? Have we thought of an alternative rather than going down you know, I'm an engineer, I'm going to design some concrete. It's like, you know, let's maybe start thinking a little bit differently.
Yeah. Cool. Anande.
Yeah, we have some questions from the public. So the first one is from Janis Mikek. And basically what he's asking is what kind of proof people get to validate the results of the web application. So is there a report of something?
Yeah, so depending on the application. So for example, the reinforced concrete slab tool that we've developed, that is automating the production of the typical design deliverables that we would normally produce manually. So a calculation, a rebar schedule, a detailed drawing. Ultimately, I think it's quite important to stress we're not automating the checking and the approval of these tools. We're just automating the production of them. They still go through that check approve process. But yeah, so depending on the product, we would produce the automated deliverables for them. So yeah, if it's a a calculation, if it's a drawing, it depends on the application.
Cool. We have another question. I think this is pain many people feel, and it's actually, how do you combine your manager or someone like the section head to really invest in programming and this kind of tools? Do you have some advice on that?
I think from my experience, having a manager that really buys into it has been really important. I don't necessarily have fantastic words of wisdom of how to deal with a manager that doesn't get it. So apologies for that. Although I'm an engineer by background, I'm not particularly interested in coming up with ridiculously complicated cost benefit analysis of things. We roughly know how long it takes us to produce things in the old-fashioned traditional way, if that's for lack of a better term. If we can produce something 60, 70, 80% quicker, we do it a lot on our project. So at Costain, we design a lot of slabs, we design a lot of tanks. If we can come up with something that's going to get us a return on our investment in 6-12 months after 3 or 4 times of use, and the investment is relatively small, I think it's a really difficult question to answer, but that they have been methods that have sort of served me well in the last couple of years.
Great. Yeah, so I think we don't have more time for questions.
So. Yeah. So I think we are finalizing. So so one last question I actually had myself for you, Joe. So let's say that so could you shortly elaborate a bit on your personal way? So how because you were also an engineer, how did you learn to program and be able to develop these kind of tools?
Yeah, so I think my route into this was an engineer who was a bit annoyed and frustrated about how things were being done manually and having to go back to square one when the goalposts moved, as it were, which happens quite a lot. So I just did a little bit. I applied for we have a sort of development budget at Costain that people can apply for. I applied for some training budget to do some FME training and some ArcGIS training, and it just sort of snowballed from there. Really, we had a small team, small capability that was starting up that had vacancies, and I joined that team, and it's really gone from there. And that was 3-4 years ago, and I now lead that team. So yeah, it's been a really interesting journey, and I think one that's going to continue, because we can always get more efficient. So there's always going to be opportunities out there.
Great. Great to hear. Well, Joe, thanks a lot for being here and your very inspiring presentation. So well, hope to see you again soon, of course. I'm really looking forward to the tools that you are developing as well. And thanks a lot, and we'll be in touch.
No, thank you very much for having me. See you later.
Right, see you.
Bye-bye.